This is a short video about balancing reactions. Now we've talked some about reactions already, where we have our reactants that are on the left-hand side of an equation and the products are on the right-hand side of an equation. We always start out with our reactants in a chemical reaction and we end up with our products. Now, according to the law of conservation of mass, the number of reactants of each atom in our reactants need to equal the number of products that we form. So those numbers can't change. That was also Dalton's fourth postulate in Dalton's atomic theory. To understand how to balance a reaction, what we need to look at are the coefficients. And the coefficients are the numbers that come before a chemical. They tell us how many of that molecule that we have. You can see in our reactants we have 2 oxygens, and that's represented here by 2 different oxygen molecules. If there is no number in front of a compound like CH4, it's assumed to be a 1. That means that we have just one of those compounds there. What we've already talked about is the subscripts. And subscripts, again, can't change. If you change a subscript, then you actually change the compound. So the subscripts tell us how many of each atom we have in a molecule. If we take a CH4 for an example, we have 1 carbon atom, that's that black one here, and then we have 4 hydrogens represented in our picture by 4 white balls. So again, you can't change the subscripts when you balance an equation, you can only change the reactants. Here's a few slides from our flip charts on how to balance an equation. What you need to do is, once you have your reaction, make a list of all the atoms that are inside in the reaction. They should be the same in both the reactants and products. So if we look at this, CH4 plus O2 goes to CO2 plus H2O, we see that we have carbon, hydrogen, and oxygen atoms. Now once we do that, we are going to make a list on the left-hand side here to show how many of each atom we have in the reactants. In CH4 we have 1 carbon, we have 4 hydrogens, and we have 2 oxygens. Now on the right-hand side of the reaction, we write down how many of each atom we have in our products. We have 1 carbon, 2 hydrogens, and then 3 oxygens, because we have 2 from CO2 and 1 from H2O.
I like blue.
Oh, good. Okay. So
I'm blue.
The last part is we need to make sure that our numbers of each atom are the same on each side of the equation. What we do here is we change our coefficients. And again, the coefficients are the numbers in front of the molecule. So what we can see from our slide before, that our hydrogen and oxygen atoms were not equal. So what we did, we put a 2 in front of this H2O, and that number factors into both of the atoms. So 2 times 2 gives us 4. 2 times 1 gives us 2 here, but we also have the 2 oxygens from CO2, so we have a total of 4. Now we can see here that in our reactants, we need to change the number of oxygens so that we have 4 oxygens. You want to check to make sure that you have the same number of each type of atom on both sides of the equation. When you do this, you're done. Sometimes problems are straightforward and easy, and sometimes they're more complicated. If your numbers start to get too big, take a break from this problem, start over, come back to it again. All right, this is a fun little reaction here for us to balance. This is H2. The bigger compounds are O2. And in our product here is what H2O looks like. So if we try and balance this reaction between hydrogen and oxygen, we can see that if in our reactants we have 1, 2, 3, 4, 5, 6 hydrogens, and we have 3 oxygens. In our products, we have 1, 2, 3, 4, 5, 6 H2Os. And if we add these up, if we make our list of atoms that we have 12 hydrogens, 6 times 2 is 12, and we have 6 oxygens in our reactants. In our products, we have 12 hydrogens and 6 oxygens. So we're all set. What I'm going to show you now is a shortcut. And this shortcut you can use, this is an example problem from your homework. You can use a shortcut if you have a polyatomic ion that's kept together in your reactants and your products. In this example, we have sulfate that's in our reactants and sulfate that's in our products. Now, in the blue here, what I wrote down is the traditional way that we've been doing, which still works, by separating all of the elements that are in our reaction. On the right-hand side, I have written in red the new way to do this. And what you'll see when we start to do our double replacement reactions on Wednesday and Friday is that this makes these problems much easier. We keep sulfate together as one, and so what we can see is that we have 1 sulfate in our reactants, and we have 3 sulfates in our products. So we can see right away that this problem's not balanced. If we go ahead and fill out all of the other information that we have for this reaction, we can also see that it's not balanced. But this gives us an easy way of keeping sulfate together. The numbers are much smaller, and it will save you some time. Good luck, and I'll see you in class.